Hello everyone. Today in this video we're going to talk about hierarchical regression and how to do that in SPSS. So in this data set we here have an outcome variable that is a depression score, and here we have two measures, two screeners for depression, and of course we hope that both of them will be able to predict depression. But here in this specific case, we're going to focus on a specific situation where we are sure to have one of them, which is the first screener. And our research question will not be, do these two screeners work, or does this one screener work? But instead, provided that we do have screener one, how would the second screener improve our prediction or identification of depression? So in other terms, here we're going to compare a model that uses the first screener to predict depression with a model that uses both screeners to predict depression. And as we covered in class, these two models that we want to compare are nested, and so we will be able to use a hierarchical regression to compare them. So I will click on Analyze, Regression, Linear, so it's essentially the same menu as for simple and multiple regression. And so in this menu, I will first put depression as my dependent variable. And then here, it's something that maybe we haven't noticed before when we use simple and multiple regression, but we can actually create multiple blocks of predictors. So here I'm going to compare a model that only has the first screening. That's my block 1. Then I will hit next to see what happens in block 2. So here there's a little bug. It doesn't show that it's block 2, but it is, right? So we have a second block, actually. Depending on your version of SPSS, you may or may not have that bug. And here I will add both screening methods. Let me select them both and put them both in the independent section here, right? So essentially I have here a first block with screening 1 and a second block with screening 1 and screening 2. We're nearly set. The only thing we will want to check in the statistics menu is the R² change, which is something that we often report. It's also called the delta R². And that's it. I will click on Continue and then OK. And so here we have essentially the comparison between the two models. So the first model has here only screening 1, and the second model has screening 1 and screening 2 as predictors. So we can see that in the first model, we have an R² of 0.28. So we essentially have 28% of the variance of depression predicted by screening 1. And here, when we add screening 2, the two predictors are able to predict about 0.3, so about 30%, 29.9% of the variance of the outcome. So that is a little better, right? And we can see the R² change here. So it's 1.9% of the variance of the outcome, right? That's the difference between these two values. And now the question is that amount significant, right? Do we have a significant improvement of the prediction? And to answer that question, we will look at here the line with the F change, right? So that's, sorry, the second line and the column with F change. And so here we essentially have an F test, which compares the two models. And here its p-value is higher than 0.05. So here we will say that this amount is not significant, right? The improvement of the prediction is not significant. Another way to say that is that model 2 is not significantly better than model 1, right? Does not significantly improve the fit. And by the way, here, between these two blocks, because we only added one predictor, right, in between these two, which is not a requirement, right? We can have blocks of that are different by more than one predictor. But here, we only added one predictor. So what will happen here is that in this model, the t-test of the parameter for screening 2 is actually going to return the same p-value as here, which is of course logical. And so if we scroll down, we can see the same p-value appearing here for model 2, and this is the t-test of the slope for screening 2 in the second model. It returns here the same p-value as the nested model comparison p-value here. Okay, I hope you enjoyed this video on hierarchical regression. Thank you for watching.